I'm Tammy Kolda, an applied mathematician, and this is Unlocking LaTeX Graphics. On this YouTube channel, I am providing a detailed how-to guide on using TikZ and PGF plots. I'm a longtime user of these tools, so I understand your frustrations. We're working our way through the contents of my book, Unlocking LaTeX Graphics, as well as some bonus materials. Please subscribe, post questions, and share with your friends and colleagues. Today's topic answers the question, is TikZ circle an operation or a node? The answer is that it can be either because the keyword circle is overloaded in TikZ. A circle is both a path operation and a node shape, depending on the context. If that's not confusing enough, they can provide the same outputs in fundamentally different ways. We'll explain this today and give some idea of which type of circle you should use in which context. Before we jump in, I'm assuming you're already a little bit familiar with TikZ. If not, go back and watch my prior videos linked in the show notes. As usual, we will create our LaTeX document at overleaf.com. Click New Project, Blank Project, and then we'll go ahead and enter the project name, TikZ Circles Path Operation versus Node Shape. We'll go ahead and create that. Before we get started, I'm going to organize a little bit. I'm going to close that left-hand side and zoom into 150%. Then we'll go ahead and put in our packages. This say we only need TikZ, and the parskip and full page package are just to make things look nice, and the hyperref package is so that I can link back to the YouTube channel and the author name. I also modified the help lines, making them lighter so that they show up a little bit better on the screen. We've learned about circle path operation and node shape in past episodes, which are linked in the show notes. First, I'll review the creation of the circle as a path operation, and then I'll show you how to do it as a node shape. So here we show the circle path operation. Note that I've specified draw here as an argument to the path command. You could also just use the shortcut /draw, but I'm making it explicit here for reasons that will soon become clear. I create a circle centered at the point 1, 1 and with a radius of 1 centimeter. So let's compile that and see what we get. Now we can also create this identical circle using a node shape. So let me go ahead and create a circle with no text as we see here. So we have a node of shaped circle, but no text. So if I compile that, actually we can't see anything. I have to have draw. So if I put draw as a path option, I want you to notice here that actually the circle does not show up. And that's because the draw in the path is not inherited by the node. So I actually have to put draw as a property of the node itself. And I don't even need it as a property of the path. So now we see a circle. Now this circle is still not the right size. That's because its default size is determined by the parameter intercept, which we covered in a previous episode on node sizing. To get the size we want, we have to specify the minimum size. And so here I'll go ahead and put that. And I had to make the minimum size as 2 centimeters, specifying the diameter rather than the radius as I did up here. So if I compile that, now we see that we have a circle that's the same as the previous one. So these are two fundamentally different ways to get a circle of radius 1 centimeter. Let's paste the code that we have above again and see that one difference between these two approaches is in the way that they handle the draw and fill path options. Adding a dashed line to the path will change the way that the circle appears. So if I add it in the first picture, and then I can also add it in the second, now we see that both circles come up as dashed. And that's because it's at the path level. We could also add dashed at the node level, but it does inherit the dashed option from the path. Now, for example, we added fill equals yellow to both. What do we expect to happen here? Well, the path operation does get the fill, but the node shape does not inherit the fill. It will fill the circle if we type fill here. It will even inherit the color, but it won't fill the circle unless we say fill explicitly as a node option. We can also override some of the path operations in our specifying of the node option. So for example, we could undo the dashed line type by typing solid as our line style. So fill and draw work as expected for a circle path operation. However, the fill and draw are not inherited by a node object and must actually be specified draw and fill explicitly. A node will, however, inherit its colors and line style from the path. Now let's look at drawing a small circle with a new example. First, I'll show you how it works when we create the small circle using the circle path operation with a radius of 2 pt. I set the fill to be orange, and so we get a little circle here with the radius of 2 points. If we try to reproduce this as a node with a circle shape, what happens? So I put circle, fill, and minimum size equals 4 pt, so the diameter rather than the radius, but this actually doesn't work. It's too big of a circle. This is because of the somewhat hidden setting, inner SEP, inner SEP. We had to set that to be 0 because the default size is 0.333 EM. And you have to go back to the video on node sizing to get an idea of what that means. But if I go ahead and set that inner SEP to 0, that means we take out this hidden space inside the node, and now we get to the specified minimum size of 4 pt. Now we can still run into problems here, as you might guess, if we put any text into the node. For example, if we add the letter X here, then the node will expand beyond the minimum size of 4 pt in order to fit that text. Of course, the flip side is that the circle path operation cannot contain text nor automatically resize to contain it. So a circle path operation has an immutable size, it will be whatever size you specify. But a circle node will always grow to contain its text and may be bigger than the specified minimum size. So that's one difference between these two. Let's consider our two original circles again, but this time I'm going to make them half the size. Circle path objects are always centered at the specified coordinate. So here I've specified the coordinate 1, 1. The same is true by default for the node. I specify the coordinate 1, 1, and that's the center of the circle. But one difference is that a circle node can be anchored pretty much wherever we want. So for example, I can add anchor equals west to this node, and it will anchor the west point of the circle node at the specified coordinate, in this case 1, 1. Or I can use any integer to specify an angle. So here I'll specify the angle 205 degrees. If I recompile that, now we see that the anchor has shifted to the point at 205 degrees on the circle. I can also name and then reference a node. So I'm going to name this one C, and then I can create another line in my TikZ picture that references that node C. In fact, here I'll reference C.205 and I'll draw a circle of radius 1.5 pt. So now you've seen a bunch of different things about the circle node type and circle path operation. I'll close by mentioning that a circle path operation can create an ellipse by specifying different x and y radii. For a node to be an ellipse, we need to use a different node shape named ellipse. And to use that, you need to load the shapes.geometric TikZ library. If you want to know more about that, give me a note in the comments. I'll also observe that the rectangle is similar to circle in that it is both a path operation and a node shape. You maybe don't think about rectangle as a node shape because it's actually the default. I hope you enjoyed today's video. You should now understand the keyword circle is overloaded in TikZ. It can be both a path operation and a node shape. And these can actually be used to produce circles that are very similar, but they do have different properties. If you want me to talk about the same phenomenon with rectangles, please let me know. This is the 5th video in a sequence of videos on nodes, so be on the lookout for more in the same sequence. There's a link to the Overleaf document in the show notes. Please click like or subscribe if you want to see more videos like this, and you can always buy my book, Unlocking LaTeX Graphics, linked in the show notes or at your favorite book retailer. Thanks for watching.